This is a presentation of correlational tests using PSPP by Colbert Guashue, California Intercontinental University. The course title, Business Research Methodology and Quantitative Statistics. Today's date, August 5, 2019. We shall, first of all, import data from Excel to PSPP, and then we're going to state our hypothesis, followed by the expose of output and results, and we conclude with takeaways. Using PSPP and the bivariate analysis, we're able to evidence a series of correlations between important economic data. The first one evidenced here is income and debt, leading to inconclusive results. As a matter of fact, the null hypothesis here is that there is no correlation between income and debt, whereas the alternative hypothesis is that there's correlation between income and debt. The correlation coefficient and its p-value were calculated using PSPP, assuming alpha equals 0.05. No significant correlation emerged. The test was inconclusive as the coefficient of correlation equals the level of significance. This is evidenced by the scatter plot. The second hypothesis test is between income and debt. The following correlation test was conducted. No hypothesis, there's no correlation between the income and savings. Alternative hypothesis, there is a correlation between income and savings. The correlation coefficient and its p-value were calculated using PSPP, assuming alpha 0.05. A significant correlation emerged as the correlation coefficient here is 0.91 and a p-value is null. The test showed a strong correlation between the two variables. In the case of income and wallet, we found a perfect correlation. Our null hypothesis here is that there is no correlation between the income and wallet. Our alternative hypothesis is that there is a correlation between income and wallet. The correlation coefficient and its p-value were calculated using PSPP, assuming alpha 0.05. Significant correlation emerged with the correlational coefficient 1 and the p-value 0. The test showed a perfect correlation between the two variables. Our fourth hypothesis test is between debt and savings. The following correlational test was conducted. Our null hypothesis here establishes that there's no correlation between the debt and savings. Our alternative hypothesis, there is a correlation between debt and savings. The correlation coefficient and its p-value were calculated using PSPP, assuming alpha 0.05. No significant correlation emerged. The test showed a weak correlation between the two variables. Therefore, we reject the null hypothesis and accept the alternative hypothesis. Our fifth correlation is between debt and stocks, and the evidence here is that there's a weak correlation found. The null hypothesis here establishes no correlation between debt and stocks. Alternative hypothesis is that there is a correlation between debt and stocks. The correlation coefficient and its p-value were calculated using PSPP, assuming alpha equals 0.05. No significant correlation emerged as the correlation coefficient 0.01 and a p-value 0.934. The test showed a weak correlation between the two variables. Therefore, we reject the null hypothesis and we accept the alternative hypothesis. Finally, our sixth hypothesis test is between debt and wallet. Our null hypothesis, there is no correlation between debt and wallet. The alternative hypothesis, there is a correlation between debt and wallet. The correlation coefficient and its p-value were calculated using PSPP, assuming alpha 0.05. No significant correlation emerged with the correlational coefficient 0.05 and the p-value 0.570. The test is inconclusive in this case as the correlational coefficient 0.05. Our major takeaways here: first, PSPP can perform correlation tools at a fast pace. Second, a test can be performed using bivariate correlation analysis. And lastly, scatter plot A to visualize the degree of correlation. Thank you for watching. Feel free to ask any questions.